All right. So this is I wanted to point out this, we'll come back to this. So in here, we've got that red bone marrow going on. When you're young, you still have red bone marrow there. We've got that compact bone, but there is some hyaline cartilage left there, and there is some hyaline cartilage left here, and we're going to talk about that. That's what's making up that epiphyseal plate / line, and we'll come back to that in a second. Okay? All right, so let's talk about how your bones have changed since you were a fetus and as you grew. So as you're a fetus, you are mostly hyaline cartilage. You had about 300 bones. We know that you have 206, so a lot of those fused together. And in lab, you're seeing those sutures and things. So those what was multiple bones have fused together. And so this is just showing a hand. You have lots of bones in your hands, and so a lot of this was cartilage, and as it was transferring over, we're getting longer bones, and then we're starting to get some things fused together. So you can see the hand developing from a newborn to an 18-year-old there. So from 0, so the minute you're born, to about 3 years old, you are still doing this endochondral ossification, which is where your hyaline cartilage is being that blueprint model. Your medullary cavity from 0 to 3 is red bone marrow. And the reason it's red is because your bones are still growing, lots of development going on from 0 to 3. You've still got lots of hyaline cartilage in your body. That's why they call it bouncy, bouncy baby. And that bones are changing into, your hyaline cartilage is changing over into your bones. From 3 to 18, we are seeing some activity at the plates, and so that is where we're going to see your length of your bones going on, and we're going to look at that in just a minute as how your bone lengthens. And then from 3 to 18 and beyond, your medullary cavity is changing over from the red marrow to the yellow marrow. And then we still have some hyaline cartilage left over. We know at the ends of your bones, we've got a bridge of your nose, your ribs, your costal ribs, and we're going to see hyaline cartilage at the joints. At this stage, you have more bone is being made than lost. And so when we say that, we would say your osteoblast. Oh my goodness, I can't spell all of a sudden. Your osteoblast are doing more than your osteoclasts. Remember, your osteocytes are just hanging out and chilling in the lacuna, so osteoclasts. These are the two types of cells that are involved in shaping your bones and remodeling your bones. The osteocytes are just like, I'm just chilling and maintaining what's here. All right, so I would like you to know these two. And so as you were growing, see, I've stopped doing this. We have two types of way, and it says postnatal bone growth. So this is after you were born, how are these bones going to get longer and how are they going to get more round? Because they don't stay that small diameter as when you were a little kid. Okay. So you have two types. So you have interstitial growth, and you have appositional growth. And what you really need to know, and we're going to go into interstitial quite a bit, is you need to know that interstitial is how your bones grow longer. So it's length, interstitial. And then appositional is how they widen, so how they get wider around. So interstitial is going to go on as long as you've got hyaline cartilage is still present in that plate area. Once that hyaline cartilage is all become bone, interstitial growth stops. For me, as my doctor told me, it was 13. So for you guys, it's probably, girls usually around 14, 15, sometimes 16. Guys can go like up to 21. So and sometimes when they hit their main growth spurt. So it just really depends. So appositional growth continues, and we're going to see that in two places. We're going to see this in the diaphysis, but it's going to be with that in between those layers, the periosteal and the endosteal layers that we were looking at a while ago. And so this will continue on through life, and this one has to do more with stresses. And if you work out, you build muscle. If you build muscle, your bones have to go along with that. So when people say they're big boned, well, that your bones get bigger if you weigh more, because your body is having to hold it. So that's why your body is responding to the stress that it has. So if you work out a lot, you have big muscles, your bones do grow for that reason. If you're carrying a lot of weight too, your bones are having to respond to that as well. So, and as you age, we know your bones get brittle and stuff like that. So, all right, so we're going to talk about interstitial growth here. So we're going to talk about that epiphyseal plate going on here. So we already talked about what's going on here and how those cavities became. So the blue that I've got here are chondrocytes. These are hyaline cartilage. These are chondrocytes. And what happens with the chondrocytes in this area here, we're kind of in the metaphysis, if you want to really say where we're at. But so the area in between the diaphysis and the epiphysis. Let me get my blue back up here. I can show here. All right, so our blue guys are chondrocytes. And so what happens with our chondrocytes, I'm just going to make it short and sweet, that they're dividing. I mean, they're growing, they're doing mitosis, and they're doing some division. But as they're growing that direction. Okay, so they're going away from the diaphysis, going towards the epiphysis. So they're going that way as they divide. So we're just making more of them, and they're dividing. I will tell you they're starting to die down here, but they're growing up there with what's going on. So they are duplicating that direction. Okay, so we get a bunch of blue guys going on here. You can see them going that way. Well, they're running and they're doing this, and then what we're having happen on this side here is we've got osteoblasts. And so these let me make them a little bit bigger, maybe color them in. These little osteoblasts are blasting down bone matrix. Well, my thing's stuck. Hold on a second. There we go. And they're going this way too. And as they go, they actually are running faster than those guys. And so these guys will go this way, and this is how our bone is growing. So as they're going this way, your bone is getting longer. It's happening at the other end too. So these guys are blasting, causing our bone to lengthen. So we're moving away from the diaphysis. Do you see it? We're going away from the diaphysis towards the epiphysis. These guys are going the same way, but they are going to go faster. It's kind of like if you're being chased and they're spitting down bone matrix. I'm getting tired of writing circles. And so what happens, eventually, these guys will overtake them. And once they overtake them, you no longer are growing. So basically, the osteoblasts have caught up with the chondrocytes, and where they catch up, it's almost like the burial line. That is called the epiphyseal line. When you stop growing, your blasts have caught up with the chondrocytes. All that hyaline cartilage in that area is gone because the osteoblasts have caught up with them, and they blasted out bone. So let me back it up. So here, this that we see under X-ray, this is the plate, the epiphyseal plate. Okay, so you can see the growth plate on X-rays and things. But as you get older and older and older, as these guys start taking over, that plate is shrinking. Even though this thing is continue going out, these will take over, and then we will see a line. So once the growth has stopped, it's no longer called the epiphyseal plate. It is called the epiphyseal line. So on my bones, and probably most of your bones, on those in that epiphyseal area, it is probably a line at this point. I know I don't draw well. It's the best I can do to give you some sort of vision of that. Okay, so here's a picture here just showing, here's the growth plate. Here's all the, and we could go into all the different crazy words that go on, but essentially it's growing. It's growing towards the epiphysis, away from the chondrocytes are, but so are the others. And that is how our bones grow. I don't know if you could see, that's a shorter one, and that's how our bones grow. So that's called interstitial growth. Interstitial growth is how our bones lengthen. And so here's some plate areas of some x-ray. I am definitely not an x-ray reader, but my understanding is they can see a gap because the cartilage does not stain, and so they can see like a little gap in the bone. And when they no longer see the gap, then it's a line. That's my understanding of the x-ray. But again, I'm not an expert with the x-rays. Okay. And you're going to see it when we get into lab and we're looking at long bones. You're going to see these lines on that, and that's what it was. I mean, the bones that we're looking at are going to be at the lines there. Now, you may have heard of people that have broken their bone in their growth plate area, and it can stunt their growth because that is how the length of the bones are developing. So that does happen. So appositional growth is how the bone gets wider, and this continues to happen through your life. Like I say, if you work out and you get bigger muscles, then your bones are going to get bigger to be able to hold that weight, etc. Muscles, fat, whatever. Also, I mean, you don't have the same size bone as you did as a baby. Think about that. But what happens is it happens inside here. We've got bones going on here, and we've got some stuff happening on the outside here. So would it make sense that we might be blasting out here and we might be clasting out here? Because if we were blasting in both locations, your bones would get so thick and so heavy. So this is happening on the periosteal area and the endo, so happening on the outside and the inside. So we are hollowing out here and adding bone here. So I don't know, you can see here better. They're adding bone here and hollowing out here as we go. So that even though the diameter is getting bigger, your bone is not filling up with just all bone. So it does, so appositional growth is how it becomes wider. So hopefully you can tell that bone before I drew all over it is much, this bone is much wider than that bone. That's what is happening here. Adding bone on the outside with those osteoblasts, an osteoclast kind of cleaning up around the inside so that it doesn't get all bone solidified, because that would be not good.